Welcome to constant of proportionality. So the constant of proportionality is ratio between two directly proportional quantities. Two quantities are directly proportional when they increase and decrease at the same rate. The constant of proportionality k is given by k equals y divided by x, where y and x are two quantities that are directly proportional to each other. Wow, what does that mean? Let me explain. If you've ever gone to get gas and you pull up and you see that gas is $2.05 per gallon, well, when you first pull up, you get 0 gallons per gas. And so you are paying $0. That is constant of proportionality. So if you're going to get 1 gallon per gas, you're going to pay $2.05. If you're going to get 2 gallons of gas, you're going to pay $4.10. That's constant proportionality. And so the way that we usually write constant proportionality is y is equal to kx. So what does this equation right here mean? That right there is how you find the constant of proportionality. This equation right here is how you find it. So let's go on and find out more. Another term for rate of change for proportional relationships is the constant of proportionality. Now, I know you've heard rate of change before. You've heard it when we were doing slope. If the rate of change is the change of y over the change of x, then so is the constant of proportionality. So we're going to do y divided by x equals k. Now keep in mind that this is also called direct variation. So we've got lots of names for this: constant of proportionality, rate of change, slope, direct variation. So keep in mind, we're still going to focus on y equals kx. And this k is what we're finding. That is your constant of proportionality. K for constant. Why is it k? I don't know. K? So let's look at some examples of how we're going to find k. Okay? So here's a chart. One of the things that we are going to need to remember when looking at charts and constant proportionality is that they always have to start at 0. Think about this. When you pull up to that gas station and you don't even put that nozzle into your car, you're not going to pay any money. 0 gallons costs $0. That's why it has to start at 0. So it will always start at 0. In this example here, we have cups of flour and batches of cookies. So it's going to take 2 cups of flour for 1 batch of cookies. So here's our x-axis and here's our y-axis. So we need to know what the k is, what our constant of proportionality is. So remember, we're going to know y equals kx. So we need to solve for k. So remember, when we're solving for k, we need to get k by itself, or you could just remember the equation. So we're going to solve for k, or the change of y over the change of x. Okay. So we're going to do our proportion here, where y over x. So we have our proportion should always be the same. So our first dot right here is going to be 1 over 2. Well, let's check this out and make sure it's in constant rate or rate of change. So our next dot here, we have 2 over 4. Well, is that the same? I don't know. Let's reduce. 2/4, it does reduce to 1/2. So we know that that is the rate of change. We could also look at our equations x and y. You would do the same thing here. Y divided by x. So 40 divided by 8 is 5. 20 divided by 4 is going to be 5. So y, every time, your k is going to be 5.